Let's take a look at number 13. If you need to, go ahead and read number 13. For this problem, they're comparing the price of 1-bedroom apartments versus 2-bedroom apartments. So they've given us 2 samples here, and they want to compare if rent for 2-bedroom apartments is significantly more on average, which means run a test to see if there's a significant difference. And we're going to compare the sample mean from 2 bedrooms versus a sample mean of 1 bedrooms. So it's about means, that tells us it's T, and we're comparing 2 groups, that tells us it is a 2-sample T test. So let's take a look at the calculator and see what this would be. Again, inference is always at the stat and then tests. And this time we said it's a 2-sample t-test, but they didn't give me the sample mean and the standard deviation. They gave me the actual sample data. So I need to input the sample data into list 1 and list 2. So let's do that first. Go to stat, edit, and enter the 1-bedroom prices, and then in list 2, enter the 2-bedroom prices in list 2. So I'll do that real quick. All right, so I've got the 1-bedroom in list 1 and 2-bedroom in list 2. So now we'll go back to our stat tests and do our 2-sample t-test. I've had a lot of questions about what is the 2-sample z-test. Remember, this is the rare scenario where we know the population standard deviations. So for example, we would know all of the standard deviation for all 1-bedroom apartments and 2-bedroom apartments in order to do a 2-sample z-test. They didn't tell us that in this problem, and they rarely ever will. So that's why we do the 2-sample t-test instead of z-test. All right, so we hit enter here, and this time they didn't give us the stats, they gave us the data. So we put the data, make sure list 1 has the 1-bedroom apartments, so that's L1, and we put the 2-bedroom apartments in list 2. The frequencies should both be 1. That just tells you how often each value occurs in the sample. And then they want to know if the 2-bedroom apartments are more expensive on average. So we're looking to see if the second sample is larger than the first sample. So that's what our alternative will be. And again, it is not pooled because we only do pooled when it's a 2-sample z-test about proportions, which is not the case here. This is about means. Then we can calculate, and it will give us our t-test statistic. That needs to be written on your note, on your paper, the do section. Your p-value, 0.029, needs to be written on your notes as well. And then, of course, your degrees of freedom also needs to be written. So remember, if you did this by hand, your degrees of freedom would be the sample size minus 1. So it'd be 9 degrees of freedom. But this is more accurate because it uses the real complex method for finding degrees of freedom. And so this is a better answer because it's more accurate. So these 3 things all need to be in the do section on your test. And then this also lists the sample information from your 2 lists. So here we get a small p-value of 0.029. So compare that to alpha, which is 0.05 most likely. Yep, it is. And so our p-value is smaller, which means we have convincing evidence against the null. We reject the null, and the null says that the prices are the same. So we have reason to believe that the 2-bedroom apartments are more expensive on average.